Sounds good.
So first of all, can you introduce yourself for the audience?
Sure. My name is Ola, and I do a lot of different things. My initial training, I'm a physical therapist. Lived 10 years in the US and got my training there from the University of Connecticut. Then I moved back over to Norway and currently work at the Norwegian School of Sports Sciences, associate professor biomechanics, motor control, exercise science, and then consult with the Norwegian Olympic Paralympic Committee. And I'm one of the founders of 1080 Motion 10 years ago, and also Athletic 1080, which is another uh, holistic approach to testing, training, and movement. So that's me. I'm very much into the implied perspective of movement. So a lot of the research that I do is geared and targeted towards the applied domain to be relevant to coaches and practitioners in the field, basically. So trying to be relevant to coaches and healthcare professionals.
Cool, I like it. So, um, the first thing I want to ask is about I know there's coaches now you use 1080 to do resisted sprint, to do assisted sprint, and I know also some of the coaches gonna use it to train deceleration. So, um, I want to start with deceleration. When you coach deceleration, is there certain key things you're gonna look into, like how their foot lands, how like the body's center of mass moves?
Yeah, I think that's a very big question for sure. We're actually um we're trying to actually put this some of our thought processes together. Damien Harper is the first author of this paper, and it's in revision right now. But we've tried to create kind of a framework for how you could start to think about these things. Because there are a number of different things that you have to consider. One, you're alluding it to it already, is the foot placement and those things. And that goes into, let's call a technical bucket, where you actually are giving cues into the technical execution. And then another thing would be some of the physical capacities or factors associated with being able to decelerate. And if we start with the physical, or bodily capacity, so to speak, I always start with dynamic postural control and landing control. So it's basically very simple types of exercises. I actually do integrate the star excursion balance test just to look at dynamic postural control unilaterally. So that's a very, very basic thing, but how is that looking? Then I usually go on to landing control. So if I can do a single leg landing, I don't impose any loads at that point. I just allow them to do it. And then I give some cues as to, okay, what are the movement strategies they have? Sometimes you see people maybe excessively flex at their hip and get, more of a forward trunk lead. So, trying to prepare them for what's coming by being a little bit more upright. And my perspective from talking about this right now, it's geared towards multi-directional sports. So this is from whether you play basketball or football or soccer. Some people call it soccer. I call it football. Um, or any other multi-directional sport. I think it's important that you get your head up and know what's going on around you. So that's like a key component there in terms of the trunk. And then from that, I might actually then introduce loading. So I'm doing like an assisted jump, very small. I control the distance because and that's where I use motorized resistance. But here if you are not smart about it and you allow the people to use assisted with high retraction speeds and high loads, they will fly through the air, and then they have to deal with the landing, which could be difficult. So then I usually give them a shorter target, like a meter and a half. Just okay, can you deal with this? Go by their successes there. So that would be another one. And then another thing that I also like to introduce is the people have a tendency to think this is all forward. I think we have to consider the fact that this is a multi-directional, meaning that yes, you can go sagittal, yes, you can go forward, but then I have my little angles that I think about. All right, I have to be able to do this at the 45, I have to be able to do this at the 90, and thereby, multi-directional when I'm doing those jumps to control or assisted jumps, if you will. So that would be and this is where a jump to land test is a classical dynamic posture control test, but nevertheless also very much linked to power and my ability to attenuate forces. So that would be one thing that I do, and then I start with assisted lunge walks, crouch walks, and then it's more of a force component for sure. Then I progress that into faster ones, more load, faster jumps, faster acceptance. Then I go into sprints to stops, starting with shorter approach distances to longer approach distances. And again, I use motorized resistance tech because it allows me to actually look at what's going on, what are the step characteristics. I get values, I get numbers on how they're doing it. How much I can weigh to the athlete is somewhat limited, but I like to have that in my back pocket and look at it if there are certain things that I see that maybe I should backtrack, or maybe this is so good I should progress a little faster. And when I do increasing approach distances, I never increase approach distances and assisted loading at the same time. I go by one. What's the right choice here? I don't know. But I think don't mix it up too much. Just do one at a time so you know what you're manipulating. I think that's important. Then I go then I go back down on the approach distance, and then I go into a change of direction. And that could be 180, that could be a 90, that could be a 45, that could be different ones. And again, I always use assisted starts because and when I say assisted start, I mean you start by running towards the motorized resistance device. Meaning that if I'm pulling you with an external force, that's going to impose a greater demand on your deceleration. That's why I always start with an assisted start. Because after all, we're talking about deceleration here, so that's how I would target it. And then we've done some studies and explored this, and we know that it seems like braking forces and the braking power are greater when I set myself up for a change of direction rather than coming to a stop. That's why I have that progression. And then the next step would be to integrate this into small-sided games and making the people aware of, this is what we're targeting. Small-sided games, smaller areas, bigger areas, smaller areas, shorter, less approach speed, lower forces, a little bit bigger area, you will impose, greater demands there. And then obviously, like you alluded to, the technique, how do I position myself? if I'm going to slow down, I need to generate horizontal force, period. That's just Newtonian physics. So it's undeniable, which means that if I'm going to generate the horizontal force, putting my foot out forward in front of me, that's a good strategy because that allows me to generate that. So that's one thing, and lower your center of mass so you just don't come in too upright. Those would be like very simple cues that I do. So I think yeah, and then foot positioning coming out of the turn, the reacceleration step, setting myself up for the reacceleration. Sometimes I see people getting too greedy and not being able to get the first step under the hip. They're kind of overreaching that first step and not being able to, explode out of the gate. So yeah, I think those are like some big rocks that I touch upon.
Cool. So,
There was a lot of information. I understand. That was a lot of information in a short period of time then. But this is how it started, very simple, and just to progress it and advance it.
cool. So, from deceleration to reacceleration, or from like deceleration to like change of direction,
Mhm.
is the eccentric force gonna be, is the eccentric force like larger from change of direction?
Yeah, so if you're looking at if you're looking at um the forces that are associated with horizontal braking or decel as compared to reacceleration, we see that number one, the forces are greater in magnitude in the deceleration as compared to reacceleration. We have to be cognizant of that. Number two, the rate of force development is also very high or higher. So we have to be cognizant of that when we introduce this into a training regime for sure. So we don't overdo it. And then looking at that, what other training do they actually do? How can we implement this into their different cycles? Because if they're in season, that could be a difficult task. In the off season, that's probably where you can do the most. So we're looking actually to do a couple of studies when it comes to that. What can we do off season, and how can we make changes off season, and prepare them for it? So from a forest perspective, yes, it is greater, and that also feeds our basic physiology, because we know that, from looking at simple joints or muscles, and we know that our eccentric force demand or capacities are greater than concentric capacities, and this is also seen at a more of a macroscopic level in a locomotive pattern, such as a change of direction, where you do see similar behavior. You have the eccentric side of things, so you almost put it into a hill curve, where you see on the deceleration side greater forces, greater RFDs, whereas on the acceleration side, smaller. Relatively, it's important. They're not small forces on the acceleration side, but it's relatively they're smaller.
So, do you think that like nowadays there are more and more coaches discussing about like deceleration, is because probably deceleration is the limiting factor of like team sport athletes?
Um, is it a limiting factor? I think this is also some of the stuff that we are doing with motorized technology and 1080 motion. And one of the things that when we started to explore these tests for change of direction, one of the things that we really wanted to do was to actually provide continuous data. So because we've always observed that, you know, some athletes might favor or go in a little slower to showcase their higher acceleration capacity, meaning they're almost camouflaging their deceleration. With continuous data during the different phases, we can look into this, and we can start to identify this, and we can start to see this. And I think that will allow us to be more targeted in our prescriptions. So that was one of the reasons why we actually did it. And then in the most recent publication, we wanted to look at the reliability, and it's a lot of data in there. But the point of that project is basically, all right, so if you're looking at these outcome measurements from a COD test, here is the reliability, here's the minimum detectable change. So we know if you're making, if you do a pre-post kind of thing, we know that if we observe these kind of differences, we know that we made a difference. And this is also where we can really start and look, are there different benchmarks that we could start to establish? And this is pretty new, so I think benchmarks would be good. Reference data would be brilliant, because then we know, is this a good way of doing it? Could it be better? You know, are there things that we could improve upon? And then I think you'll find that, yes, certain players on a team might benefit from it, whereas others are pretty solid, so maybe focus elsewhere. But I think that is to be determined. I think, but is it an important factor? Absolutely. And if we start to look at injuries and injury preventions and all those things, we know that, you know, deceleration is where it happens, unfortunately. Being more cognizant and aware, and maybe, you know, put that into our injury prevention programs or training programs. Who knows, maybe that could have a positive impact. But then we would need empirical data to actually make that inference and say, well, yes, it is injury preventive. But I think based upon observations, it has a possibility or an opportunity to be so. Whether or not it is by itself remains to be seen for sure. And again, you know, injuries are so multifactorial. It's not very likely that one singular factor is going to predict. So it could be one factor of many.
Yeah.
But having this awareness and having these data and being able to look at it and explore it, to me, it makes a lot of sense.
So for teaching movement, we oftentimes like categorize like linear acceleration or like multi-directional movement, change of direction. And we separate like linear is one day and like multi is the other day. Do you think we should uh deceleration on a certain day or put it into that same day, like linear direction and multi-direction?
Oh, that's a good question. I think it depends on where you are in the season. Because I would be very wary of introducing a lot of multi-directional decelerations in season. I would be very careful in doing that. Let's say that we have a big roster. I think that could be a good thing, maybe, to introduce to those players who didn't play that much. They're bench players, those kind of players that didn't get the exposure. Then having that understanding and giving them that exposure, I think, could be a golden opportunity. For those who are playing a lot and frequently, then it's just probably better to get them back on their feet and not impose more damage, so to speak. So that could be one thing. If I am in a multi-directional sport, should we mix it up? let's use the example of basketball. If you're in basketball, I would probably mix it up a little bit, because the thing is that, and again, I would probably test acceleration, linear acceleration, from different starting positions and by starting positions, I mean, we usually test linear acceleration from a preferred pattern or stance position, usually 2-point start with the preferred foot forward. Most people choose left foot forward, so it's a left stride pattern. Why not try a right stride pattern? Because you have to accelerate out of that as well. How about just neutral stance? So you have to go into a split step and then accelerate. How about rotated left, rotated right? So you actually have like different starting positions to actually then work on explosion or linear acceleration. And then an acceleration by itself is good, but that leads to something else, you know. It's some sort of transition into something. That's the reality of it. So including that into it would be good. And then another thing that I think also people disregard sometimes, how do we actually put in different locomotive patterns? Because we do running, but if I'm in basketball, why don't we go to side shuffle, cross steps, and do these other locomotive patterns too in conjunction with that? So I'm accelerating using this locomotive pattern, and then I have a transition into this other locomotive pattern. It could be forward to backward, it could be backward to forward. And again, looking at the sport and what they can do on the court and versus where they might be struggling with different movements, I think it'd be very, very interesting. So I think that is how I would think about it. It really all depends on your sport, and it's multi-directional transitions. That's the name of the game. Say, for instance, if I had a tennis player, I would probably think a little different, because then I have a lot of baseline transitions, whereas I don't go as much forward and backwards. So then I might, you know, put it together a little bit differently based upon the nature of the game. So that would be different than basketball or football for that matter. So yeah, I would probably mix it up, but not do too much, because when we've done these deceleration things, and especially with external loading, you have to be careful how much you introduce. You
Yeah.
have to have a slow progression and think about the total volume, because we know that acute increases in workload, and if we impose a external demand, we have to be cognizant of that.
Yeah. So, I know like some coaches gonna utilize 1080 to train deceleration, and
Mhm.
I also know like uh coaches use 1080 to do assisted sprinting. So when we use like 1080 to maybe coach over speed training or assisted sprinting, how can we make sure they're not actually decelerating?
Uh-huh. That's a really good question. I think there's some cool things, and then we don't know too much about assisted sprinting. If you're looking at and that's from a literature perspective, that's from the science, the body of knowledge, you know, in published work, but there's a lot of experience out there in the world on this topic, for sure. But I think, the assisted sprinting, um, I think there was a small little study done by Coach Potts that is published on Simply Faster, where I actually did assisted sprinting, and what he did find was a improvement in that 0 to 5, 0 to 10 time interval, which is kind of, this is the most force demanding part of the sprint. but nevertheless, assisted sprinting, where you get assistance and help, actually was beneficial. Was very positive for this, which is maybe it's kind of like a neuromuscular coordinative thing. I'm able to get my feet into position faster and thereby allowing me to have a better acceleration. So that was very interesting. And another one, a lot of you might also think about it a little different, where you say, all right, if I'm having assisted sprinting, I'm being pulled, I'm using less energy to get into speed, I can stay at the higher speed for a longer period of time and expose myself to that. That is also a very nice approach to assisted sprinting. Then to your question, how do I know that they're not slamming on the brakes? And this is where actually looking at the frequencies of the locomotive pattern. I think Chris Corfitz, an excellent track and field coach from Chicago, has done a lot of cool things with wickets and ensuring that you have your frequency maintained so you don't end up floating. And another thing that you can do with the in assisted sprinting too is looking at the at a split time or a split interval, you're getting into your speed. And then the question becomes, is it truly overspeed or not? Because it could be, like you're saying, they're braking. What you can look at then is, or at least how we've approached it, and many coaches do, is that you impose a pulling force, and then you look at the 10-meter split. If that 10-meter split keeps on going down, they're actually able to run faster and faster and faster. And then it reaches a point where if you have too much pulling force, the best 10-meter split time might go up, which means that they're not really they're actually slowing down or braking. So that could be a proxy measure of them not actually being able to utilize it or take advantage of it. So split times could be helpful in that regards.
Can we use 1080 to watch to get split times, or do we
Yeah.
have to use like timing gate?
No, you can get split. You can get the splits that you want, and you can set the split distances. And we use the empirical system or the metric system because you could use your yardage, and say if you're in American football, you want to use yards because that's how you do it. Whereas more of a classic track and field coach would be more like 5-meter splits or 10-meter splits. And then if you have continuous velocity measurements, you can obviously get the different splits and monitor those. And that's usually what I do.
Yeah. So go back to like deceleration. Um and I know you probably answered this at the beginning. Um but for those like football or like rugby player, they have like American football, they have like crazy acceleration and crazy amount of like deceleration or change of direction during the game. Uh, are you gonna like when training, if it's like off season, are you gonna like increase, or how are you gonna increase the deceleration load?
No, I would say that's also dependent upon positioning, right? Like, okay, which position would require you to be able to be good at deceleration versus, well, having some level of being able to slow things down is obviously important. But then there are different positions that will have greater, demands for it or need for it because it's a part of, you slam on the brake or you stop on a dime, people sometimes say that could be very helpful to create space. And if this is evident to it, like in goal scoring opportunities, deceleration capacities is important to outmaneuver your opponent. It's like you're stopping on a diamond, boom, you're exploding away. So having that capacity is very important. How would you progress that loading? And I think, yeah, I touched on it a little bit going in. I think there are like two things that you manipulate. Well, three things that I would start with. Number one is approach speed and giving a deceleration distance and monitor their max speed. Because if you see their max speed dropping, that's going to decrease your deceleration demand now, isn't it? So if you set a distance of say 10 meters or 15 meters and what have you, making sure that they reach a certain target of their approach speed and then slam on the brakes. You could try to set up and change the deceleration zone by using external cues such as cones. You give them the instruction. I want you to do this. I want you to complete it from here to here as fast as possible. So they have to solve the task, and then you look at the speed and what it was. Then the other one, if you're going to go into a transition, you have to think about, if you're going into transitions, lower angles, it's more of like a speed dominant change of direction, obviously associated with less force. So that's more of a speed perspective. Anything from 90 degrees and upwards, then it's more of a force dominant change of direction, which means that more force is going to be associated with it. So the angle of the turn is important. Then, so angle of the turn, the approach distance, how much speed am I assuming? It's basically a drop jump. The approach distance is the same as the height in a drop jump, because I'm giving you more speed to deal with, or you choose to assume speed to deal with. In a drop jump, it's like you get up on something and you're like, okay, no, I can't land this, so I take a step down, then I can land. So it's basically the height of the box or whatever that you're jumping off of. That's your approach distance. And then the pulling force, is also another variable that you upregulate. That's almost like a drop jump with an additional load, right? So you don't go up on the highest point with a lot of additional load, and then you do a drop jump. That's not your progression. So then you do a gradual increase, the way that we've done it, because it's very difficult to get an RM out of this. Like, so you can set a certain percentage. So we have started to standardize this based upon percentages of body weight, because you have some heavier people that it's their mass that they have to stop plus something normalized to their mass. So I would say that would be some of the progressions from a physical perspective.
Nice. I like it. I like it. So, um,
And one thing there too, like, don't complicate it too much, don't get too fancy, it's like it's I'm manipulating this variable, I'm doing this number of reps and this number of sets, I'm going to go fast, I'm going to go slow, it's don't yeah. So I would say those three variables: angle, approach distance, external load.
I got you. So, one thing I noticed about the 1080 is you can get all kinds of data from 1080,
Sure.
and it's basically kind of like a moving force plate.
Yeah, it's not a bad comparison. Yeah, it's like
So,
yeah.
so what are the thought process of like designing or like putting all this together?
Putting the system, the
Yeah.
1080 together. Yeah, no, that goes back to one of the reasons why I'm involved here. Basically, it's that we wanted to Because we obviously have different systems. We have the 1080 quantum, the cable, and then the sprint, and dimension some there. The thing is that we wanted freedom to operate and freedom to move, right? Because if you look historically, like a lot of force measurements was, you know, your isokinetic dynamometers and uniplanar, one joint, one plane, one direction. So we wanted the freedom to move and do that in different kind of movements to free up the system, so to speak. We can do isolated joint, sure. We can do partial kinetic kinematic chain. We can do a full kinematic chain, and then we can do locomotive patterns. So, and that's the name 1080 because it's 360 degrees, 3 planes of motion. So it's basically the freedom to move. That's what it stands for. So 1080 motion, freedom to operate while I load you up in that. So that was the reasoning, or one of the reasoning. And then, we obviously have different types of resistance or different ways that we can obtain information from people. We could do just traditional loading. We impose a certain load to you, and then we manipulate how the load behaves, meaning that it could behave like a mass in a gravitational field. It could be isotonic or towards isotonic, or it could be quote unquote normal, which is the mass in a gravitational field. And then we have something that we call no flying weight, which is a type of resistance setting that the weight doesn't fly away from you. Because if you've been jumping with for instance, a bar and weight on it, it kind of like flies away, and then you have this little impact when you land with it. So we wanted the load to stay with you, so you didn't get that slack in the line, so to speak. So that's what we call no flying weight. And then we can do eccentric overload. So we can contrast it, and that's also a very variable type of resistance in change of direction, because I use that actually quite a bit there, in that I give you more eccentrically or assisted. So when you're running towards the machine, you have to deal with more than when you turn around and run away from the machine. So you get an eccentric overload. That could be done in a squat, it could be done in a change of direction. It doesn't really matter. It's the same kind of thought process. This to target the fact that you do generate more force and are stronger eccentrically than concentrically. Then you have super maximal eccentrics. Obviously, that is not related to change of direction, but say you do a Bulgarian split or a squat or something, we impose a external load that you cannot reverse, meaning that you cannot turn it into a concentric action because the external load is too big. This is where you have to be careful, and you have to instruct your athletes or the people that you work with very carefully that you're gonna fight it. And we're gonna calibrate the system within the physiological range. We have all these safety measures when we do that. And then we give them a target force to try to reach, and it's not necessarily, everything you got every single time, every single session, because that becomes, extremely demanding. And then another thing that we manipulate is speed, because if you think of force velocity, it's force. So we manipulate load, manipulate the behavior of that load, and then we manipulate the speed. So that's when we can go and put on the handbrake of any kind of movement, really. And that's when you're getting into isokinetics, which could be really good for rehab purposes or just pure straight up strengthening as a strength program. And then we get all sorts of data, like you alluded to. This is where you start out pretty, I would say, like, from a discrete movement, like a squat or a Bulgarian, okay, peak average force, power, speed, those kind of things. And then you can get into, different things, more fancy things as you move along. Because it gives you the opportunity to do so. For instance, for a change of direction, I usually start with total time, split it, phases, the initial acceleration to deceleration time versus the reacceleration time. You look at those ratios. Then you split it further into subphases, and then you look at the times. And times are also very easy to communicate when you're doing locomotive patterns, because that's a very common way of communicating it, right? Because it's people know and understand a 0 to 5 time. If I start to get into forces and accelerations and all these other things, people might get a little confused and don't understand what it means. So it's communication here is also very important, especially in communicating with other coaches and athletes, because you don't want to overwhelm them, and you want to give them meaningful things, right? That is key. And reporting that, and so you get a buy-in, so they understand what they're doing, why they're doing it. This is what happened. This is how we can change it. And then once you educate your athletes and you work more with them, you can start to expose them to more data. And it's like, okay, look at the slope here. All right, I want you to actually see if you can be a little bit more abrupt here. Sometimes on deceleration, I do that. I show them the curve, I give them that information and what it means, and then they go out and they try to change it. I know certain tennis organizations do it that way, and with great results. So, but that is dependent upon the knowledge and the maturity of the athletes that you're working with.
I like your approach. So, kind of want to go back to like deceleration a bit and ask about like there there's one time I tried to like I saw an athlete move and he kind of moved like his movement efficiency isn't that good, and I introduced a little like linear deceleration, and somehow it's a basketball player, so somehow the player just moves so efficient. So my question is, do you think that linear deceleration is going to transfer or is have a good transfer to like multi-directional? I mean, if we only change linear deceleration.
And by linear, you're thinking going straight forward.
Yeah.
Yes and no. There are going to be similarities and there are going to be differences. I've tested and I worked with different athletes, and sometimes you'll be surprised what you find when. And one approach that we did to this was that we looked at, going sideways and going forward and stopping, and all of a sudden you might have one leg in one direction that is not really doing all that great. And we tested the whole football team, pro football team, and we looked at vertical versus forward versus lateral, and the correlations were not that great, which means that is telling me that there is some sort of specificity to the directionality of being able to express force. Just because you're good forward does not necessarily mean that you're good sideways. And if I'm going to be working with say we have a basketball team, if I'm going to be working with one basketball team, I would like to know, are they good sideways, forwards, backwards? Because you might, and these are things that you might see on the court. Because if I know that if I'm going to explode off my left going to my right, I'm not as good going to my right as to my left. You might see them favoring that positioning. Now I'm thinking defensively. They might be favoring that positioning, and you might see it on the court. And if you're able to piece this together and then talk to the head coach, and the head coach is like, whoa, this strength coach is, or performance coach is seeing that in what he's doing over here. That's really cool. I'm going to listen now, because that's, to me, is very important information, because this is what some of the shortcomings I'm seeing from this particular athlete on the court. So I would say yes and no. And sometimes you'd be surprised, because we've done vertically, counter movement jump is a vertical change of direction. We've done that with the expectation that that is also going to explain all these other ones. Not necessarily the case. Are there going to be similarities? Yes, absolutely. Because if if I'm poor vertically, I'm probably also going to be pretty poor sideways. But vertically, I've been exposed to maybe a little bit more, and then laterally, maybe I haven't integrated that enough into my resource training in terms of, you know, different physical qualities. So this is also a little bit of speculation on my end, but I'd like to at least explore it to see what it is, you know, before I jump to any conclusions there.
So basically,
But there is certainly some transfer, yeah.
what we can get from 1080 is like 360 then 360 degrees of like data, like force plate. We only can get vertical, but in 1080 we can get like all kinds of data from different direction. That's so nice.
Yeah. And again, it's like it's a tool, and a good tool put in the right hands can be very potent and very powerful. But you just have to know how to set it up, how to program it, how to put it into your testing protocols, putting into your training protocols. And the cool thing about this, the 1080 Sprint 2 that we have now, is that it's very mobile. I have it here in my office, and I bring it out into the gym. So I put it up. I do, you know, a little bit of, you know, isokinetic Bulgarian splits on it, and then I go into deceleration steps, and then I you know, do some hip rehab, and then I can do a lot of things with one little piece of kit. But again, that's based upon the knowledge and of the user. Um, so that's if he or she can put it into play, it can be very powerful. Yes.
Nice. That's basically all the question I have for today. So for all those who are interested in what we're talking about today, where can they reach out to you?
They can find me. I'm like I'm not like a big social media guy, on and off social media guy kind of. But LinkedIn, you can find my profile on LinkedIn. I actually like LinkedIn because you can have longer posts and people can read a little bit more. So that would be my name on LinkedIn, obviously. Uh, I'm on Twitter. I don't even remember my Twitter tag, which is pretty terrible. But it's my full name on Instagram, but on Twitter at Ola Athletic 1080. That's my Twitter tag. Yeah, and then obviously I'm listed with my email at the Norwegian School of Sports Sciences. So it's my full name, or you could use Ola E at NIH, which is Norwegian. Yeah, it's the Norwegian abbreviations. I'm not gonna get into that, but NIH.no. So that's in Norway.
Cool.